Symphyotrichum georgianum, commonly known as the Georgia aster, is a member of Asteraceae, the sunflower family. The Georgia aster is a tall, skinny plant with purple flower petals and a white center that often darkens to purple. Most asters have a yellow center, making this species an unusual sample of its family. Georgia asters are capable of reproducing both sexually by small airborne seeds and asexually by rhizomes. It is a late blooming, so it is an important nectar source for pollinators, a last meal of sorts, as the fall settles into winter. It can be found in southeastern United States, although it is believed to be extinct in Florida. The Georgia aster has been listed as a federally vulnerable species since 2009. They live in sunny, open fields. However, these areas are often disturbed by humans as we encroach on natural areas. There are only a handful of wild populations of Georgia aster left, ranging from 10 to 500 stems. These populations may only have one or two genotypes, which leaves the aster vulnerable to disease. Therefore, I have decided to learn as much as I can about this plant in order to help save it. With the help of the Huntsville Botanical Garden, I have been focusing on the best way to mass-produce Georgia aster in a greenhouse setting, with the goal of giving them to members of our community. It is hoped that with time we can repopulate the southeast with this beautiful flower. I am currently testing the germination preferences of the Georgia aster. Some plants require high heat, simulating the coming of summer, to germinate, while others don't mind the chilly weather of early spring. I planted 3 waves of seeds, the first in January, the second in March, and the third in April. This staggered planting shows a good ambient temperature gradient from winter into spring. Since the seeds are airborne, I decided to find out if the Georgia aster prefers to grow on top of the soil or if it prefers to be buried, such as from a passing animal. To test this theory, I've planted half the seeds of each wave a 1/4 inch deep in the tray. The other half I placed on top of the soil and covered with a light layer of vermiculite. The vermiculite allows sunlight to get through to the seed and keeps the seed moist. To determine if the seeds require extra heat to germinate, I placed half of each planting, 1 tray of soil and 1 tray of vermiculite, onto a heating pad set to 88 degrees Fahrenheit. The other half of the seeds I placed on the table, leaving them dependent on the greenhouse environment for its soil temperature. I have determined that the Georgia aster is not a picky plant, as some plants can be. It has grown well in all growing conditions, though it shows a slightly more vigorous growth rate when it is exposed to more heat rather than cooler temperatures, and when covered with vermiculite rather than buried in the soil. It is definitely not difficult to grow Georgia asters in a greenhouse with the setup that the Huntsville Botanical Garden has, so there may very well be hope for this plant. The results of this project will directly benefit local conservation groups by increasing our knowledge of this plant. A better understanding of the germination requirements will allow all of us to produce the Georgia aster in large numbers and repopulate our city with this wildflower. It is hoped that we can bring it back from the brink of extinction. In turn, we can improve and vary the diet of our local pollinators, helping to bring up their dwindling numbers as well. Studying this plant can benefit our local ecosystem in ways we might not even realize.